So every year, all around the world, people have these UFO sightings. Okay, so they report these sightings, and a group of volunteers will collect all the data together and store it in a massive CSV file. We're going to look at just a subset of that data that starts at the beginning of 2013 and ends at the end of the following year. Interesting fact. The United States has by far the most reported UFO sightings at a whopping 8,021. This happens to be 891 times the number of sightings reported in Germany. So with such a cool data set at my disposal, I thought, hey, this is the perfect opportunity to explore GraphQL in some more detail. And I hope that by the end of this talk, you yourself will have a better grip on this technology. So today's agenda is going to consist of the following. First, we're going to talk about the basics. What is the bare minimum you need to understand in order to see the benefits and the power of GraphQL? Next, we're going to talk about a GraphQL server. What are the various components of a GraphQL server? And we're going to look at a reference implementation that's entirely in Kotlin. And then finally, we're going to take a look at a GraphQL client, and it happens to be written in Android because, hi, I'm an Android developer. And then we'll explore the various pieces of a GraphQL client and what it takes in order to implement one. So let's start by looking at the basics. We're going to look at three things that GraphQL is and GraphQL is not. So first, GraphQL is a query language for your API. Now, what do we mean when we say query language? It's best to see an example. What is this? Just yell it out. Right, SQL, SQL, this is SQL query. So a query language is any kind of programming language that allows you to get some data from a system. In this case, we're getting data from a database. Query languages also have certain keywords. These are things that let you know what and where of the results that you're looking for. So in this example, select and from are keywords of the SQL query language, right? So in an SQL world, this query would be run, it'll talk to a database, and then the database will give back some results, like a list of names. But let's look at this in a GraphQL world. And in order to understand the different examples that I'm going to show you today, we need to understand this Kotlin data class. So this is how we are representing a UFO sighting in this entire sample app that I'll show you. And then we're going to look at how GraphQL allows you to get this data and to choose specifically the pieces of it that you're interested in. So let's start with what a GraphQL query looks like. This is a GraphQL query. It also contains keywords that are used to determine your results. So the first part is the operation type. Now in this example, it's a query, but it could also be a mutation or a subscription or anything that GraphQL decides to put out there for us in the future. The next piece is the operation name. This is mostly optional, but it's useful if you want to do some debugging or for various server-side implementations. The next part consists of the object or objects that you're interested in. So in this case, we want a list of UFO sightings. And then the final piece are the fields that we want. So we don't want all the data that we saw before. We only want the ID and the shape. So when we look at this GraphQL query, unlike SQL, which talks to a database, we're going to talk to our GraphQL server or our API. And then we're also going to get back some results. And it looks very familiar. It's JSON. So if we take a closer look at this result that we get back, it's just a regular JSON object that has a data property. And inside of that data property is what we requested. So we asked for a list of UFO sightings. We get back a list of UFO sightings, but only those two fields that we were interested in. Okay, so if you want to compare operations with GraphQL to what you get with REST, it will look something like this. So we've seen query, and it's similar to making a HTTP GET request, whereas a mutation is mostly all the rest of it. And I really like to have this mental model in mind whenever I'm working with GraphQL because it makes it more accessible to me. And when I first heard mutation, I just thought about Ninja Turtles. I don't know if that's a thing in Europe, but that's the first thing I thought. And now that I have this mental model in my head, I go, oh, okay, it's all the other things other than just making a GET request. GraphQL is not actually all about graph databases. That's another thing that you'll hear people say, well, I don't need GraphQL, I don't use MongoDB or Neo4j or anything like that. But that's not what GraphQL is about. The graph in the name is actually related to how you should think about your business domain. So let's look at an example. Let's say you have a blog, and this blog has users. And then those users write posts. Those posts have comments, and the comment can be by user. So this is somewhat of a graph structure, a way to think about your data, and this is what GraphQL allows you to do. Next, GraphQL is a specification. What that means is it defines a type system along with a simple query language. It was developed by Facebook, and you can find it online, all the documentation. You can read ad nauseum about what the specification consists of. But what's really awesome about the fact that it's just a specification is that this allows you to define not only how the information you request is presented, but then also how you receive that information. So the GraphQL is handling both sides of the puzzle. And so this allows you to also write it in any language you want. So there are various GraphQL implementations for the server side in all of these languages and a few more. And the same thing applies for the client. So today we're going to look at a Kotlin server-side client, and then we'll look at a Java client, but then it's all written using Kotlin. So the next thing about GraphQL is that it's introspective, right? So it's not a word we hear all the time, but it basically means that GraphQL itself is queryable, okay? Now what does that mean? This is an example of an introspection query. So just like before, we see that it starts with the word query, but what's different now is we have this meta field, which is __ type, which allows us to get information about our schema that we've created. So here I say, I'm interested in that UFO sighting object that you have, and I actually want the names of all of the fields. So if we took this query and we ran it, so here we are, this is the query, we're running it, we get back the very similar structure. We're getting back JSON inside of a data object with the list of all the fields that are part of this object. And it's really powerful because it allows you to have a lot of tools to make working with GraphQL easier, the fact that it's introspective. So when we look at GraphQL, what is it? It's a query language, a specification, and we saw that it's introspective. But it also has a lot of other features which are a little more advanced for getting a grip on GraphQL talk, but we'll look at a few other principles later on as well. But so what? Like, why would someone want to make the move to GraphQL from REST? So first, let's talk a little bit about some of the challenges that come with working with a REST API. Often, let's say you wanted to get a list of UFO sightings. So you might have this endpoint /UFO-sightings. And then you would get back a list of all the information, and each item in that list would contain all the fields of your data object, even though you may only be interested in, let's say, the ID and the shape. So when you're working with REST, you tend to get back bloated responses, lots of things that you're not interested in. Also, it can be very challenging to perform nested queries. What if I wanted the names of the users who reported these UFO sightings? It just gets deeper and deeper and deeper with REST. And GraphQL is trying to smash this, blow this out of the water, no more working with some of these challenges. And how is it that GraphQL can do that? Well, first, we've already seen you only get what you ask for. So if you say, I want the UFO sighting with this ID, and I only want these 3 fields, then that's the only thing that you're going to get back. Also, instead of making multiple requests to get your data, you can do it in just one shot. And this is especially useful for people who are working like with maybe mobile applications and you're sort of constrained in how many downloads that you can make. Here we are, we're getting some sightings and the top country sightings all in the same request. So it's really powerful. And then finally, documentation is readily available for you. So right out of the box, your front-end developers can access the documentation and can understand, okay, what things can I query from my API? And what do those objects look like? What are the fields of those objects? So with the basics under our belt, we can move on to looking at a GraphQL server and what that takes. So the first thing to note is that there's this single endpoint / GraphQL. This is what allows you to interact with your server. Now, you would typically send an HTTP GET request, and there's this query parameter. Inside the query parameter is just a string that contains your GraphQL query. So that's one way you can do it. You can also do it via a post request to that same / GraphQL endpoint, except this time you're going to send some JSON, and there's a property called query which contains the string. Now, why is something like this really powerful? Well, it allows you to work with your existing tools. So here I am inside Postman. Now, how many people have used Postman before? Great, like basically everyone. So you should just use GraphQL now if you don't already. So we're here inside Postman. We're just making a regular query, and I'm getting back my results. So that's the key thing to understand about GraphQL. It's still just over HTTP. So you don't have to learn some whole new fancy way to interact with the network in order to get back your GraphQL results. And then here's a slightly more complex example. Here I've made use of variables. So it's just another property on my JSON object. I set it equal to 2, the size, and then you'll see like the $ size inside of my query parameters, and it gives me back the same result as before. But now you've seen just like one step further of what you can do with GraphQL and querying. Okay, so let's look at what it took to build our UFO sighting GraphQL server entirely in Kotlin. So first, I used Ktor because I wanted to use Kotlin, and it's a really simple but powerful server framework. Next, Coin was used for dependency injection. So I know a lot of people maybe have heard of Dagger, but we use Coin here. Squash, this was for like our ORM or data access layer, also Kotlin library. And then the star of the show was GraphQL, which gives us our GraphQL support. So a GraphQL server consists of these 3 things: types, schemas, and resolvers. So we're just going to look at each thing one by one. And we'll start out by looking at the types. Okay. So in this example, we've defined our own type, which is a UFO sighting. And we've specified that it only has these 2 fields, an ID and a city. And the type of the ID is an int with the bang, and then the city just string. And what this means is that the ID is guaranteed to always be non-nullable, whereas the city could be null. So that's all that means. And the fact that we've defined ID and city as scalars means that we can't nest it. We can't then create a query where we say, like, I want to get some more information out of an ID. That would just be wrong. This is how GraphQL works with the schema in order to make sure it gives you back the proper results and knows how to handle the various queries that you send in. So if we wanted to specify this in GraphQL, we have this type function that takes in the data class. And then we have our data class. We define the types, the same thing that we'd want to have in our schema definition. And then these 2 things are basically the same. So here it is, GraphQL schema language, and then here it is in Kotlin using the GraphQL library. So very simple, very similar to each other. So these 2 things are equivalent. Now the thing that connects all the various pieces together is the schema. So let's focus on that next. Now, the schema is basically just a few object types, and this is where you'll define what those object types are and what they return. So we start with the query, and the query type will give us back a citing with an ID, and then it'll return the UFO citing. So everything is connecting to each other. And then finally, at the very tippy top is our UFO citing again. So we started with the schema that has a query. This is the query, has a citing, and that's what a UFO citing looks like. So the schema is the thing that allows the client and the server to work together because it specifies what types of queries the client is allowed to make as well as the various types of the system. So here is how this would look with our Kotlin library, GraphQL. So we specify our schema, once again, our type. We have a query where we give it a name, and then you see that there is this new keyword popped up there, resolver. And that's really important, so let's go on to that one next. The resolver is that function which determines how the types in the fields are related to each other. Okay, so let's look at an example of a resolver. In this instance, someone wants to get a citing by an ID. So here in the resolver, it takes in an ID of type integer, and then we're just going to call our storage and get the citing. So in this example, we're going to make a call to our Squash database and get back the UFO citing record. But it could have just as easily been a REST endpoint. So really the resolver, it doesn't matter where the resolver is getting its data from. The key thing is that to the client, it knows if I make a query for citing and I give you an ID, then you'll give me back what I'm interested in, no matter where you get the data from. So that's really nice. Now, when GraphQL gets a query, it's going to go through and run the resolver for each field. So in this example, I say I want a UFO citing with an ID of 45. I want the ID, the shape, but I also want some information about the user who reported this citing. So it'll start at that root query that we saw before, and it'll say, okay, I see citing. Now I need to run a resolver for that. It'll look at the ID and shape, and it knows, okay, these are scalar things, so I can just give those back to you. But then the user is actually another object. So I need to run the resolver for the user. And then inside there, there's an ID and name, which are scalar fields, and it will give all of this back to you as JSON. So that's how the resolvers are working together. Now let's look at one more example. This time, it's of a mutation. So the mutation changes data or adds data. We have a description, and then we have an input, and we create the record. So it's very similar to a query. In fact, there's nothing that stops you from mutating data when you have a query resolver. That will be irresponsible, but that's your choice. So mutations, very, very similar to queries. And just how you see how all the dots are connected, this is the schema that results from all the work we just did. So we'll have names of things, descriptions, types, everything that we need in order to work with this system inside of our client. Okay, and then finally, I want to show you the GraphQL endpoint in KTOR. So it's very simple, like it looks like a lot of code, but the key point is this. You create a schema, a request comes in, and you give it your query and your variables. And that's it. It does all the work of going through, handling the nesting, figuring out how to resolve the objects to the fields, and then gives you back the result as JSON. Okay, so the key thing to keep in mind about GraphQL is that the server knows all about your schema. It's just waiting for an opportunity to get a query in order to execute the resolvers that are needed to give you back the data. So that's all there is to working with the GraphQL server. Okay, so let's take a look at the client. And this is how we're actually going to interact with our server. And since I'm an Android developer, I decided to make an Android app. And it's going to be in Kotlin. We use architecture components. And then the star of the show, in this case, is the Apollo Android library. So to get our integration going, we're going to need these three things: the Apollo client, a schema, and .graphql files. So let's look at these one at a time. First is the Apollo client, and this is what allows you to edit any sort of networking options you want to have, specify your GraphQL endpoint, and things like that. So if you look at it here, is there another library that looks very similar to this? Retrofit, maybe? Okay, yeah, so if you are using Retrofit, it uses the same sort of Fluent API, it should be very familiar, and it actually uses, like I said, OKHTTP under the hood, which is kind of like what we saw from the Scarlet WebSocket library earlier, so very similar for developers to interact with the Apollo client. Okay, next, we need to get the schema, because this is how we actually interact with our server. And we would use this command line tool, Apollo CodeGen, and then would store it inside of our application. So we have this main GraphQL folder, and then there's our schema.json. And this is how it looks. So just a giant JSON file full of all the information about every object we've created, all the fields on the objects, what they return back, everything. So we need to have that locally, and then finally is the .graphql file, and this file is going to hold all of the queries that we want to execute. So we've seen this one before, where we're going to get a list of UFO sightings, we're using the same $ size for our variables, and then we're specifying the few fields that we're going to use inside of our Android application. Okay, so how does this work? Well, the Apollo Android library actually uses code generation, which we also learned about some earlier. And it will take that .graphql file, pop it into the plugin, and then it'll spit out another file with 3 nested classes. So what's really powerful about the plugin is that you don't have to write any sort of network parsing code. It's just going to take what it reads from the schema.json and the query you've created in your .graphql file, and it's going to create everything you need to make requests and parse those requests, which is really nice. So here's an example of one of the files that's generated, and it uses the operation name, so sightings query, and then inside of it you see these nested classes that I just spoke about. So the builder, the variables, the data, and a sighting. And if you take a peek inside this particular piece of code, then you'll see that there's this builder class, and inside the builder, we have some maps of objects, and it's going back and forth doing all of this marshalling for us. So we don't have to handle any of it, even though it is written in Java. Okay, so now, how do we take these 3 things and come up with this, recycler view list of items inside of our application? Well, it's a 3-step process. So first we build our query, we enqueue the requests, and then we handle the response. Now, what does that look like, building our query? It's just a very simple builder, actually, and this is part of the generated code. And in this case, I wanted 30 sightings on my home page, so I just set the size for my variables. Next, I take that query and I pass it to the Apollo client. It has a query method. And then I enqueue the response. So very similar to working with something like Retrofit, just boom, boom, boom. And then finally, I have some callbacks where I can deal with successful response or failure. And the key thing here is that the API is actually going to return to you JSON inside of data, inside of sightings, but you don't have to worry about that at all because the plugin is just going to give you back sightings. So no parsing in you don't have to worry about doing anything fancy. The plugin and the generated code handles all of that for you. You just grab the data and display it. And this is how we were able to take advantage of GraphQL to power the Android application. But I don't want to leave you without a few tips and tricks just to make your journey to GraphQL smoother if you haven't started working with it yet. So first things first, use the IntelliJ GraphQL plugin. It's where I've got these little screenshots from. So I want to quickly show you what it looks like. Okay, Great. So first thing is it kind of gives you this whole like color-coded way to look at your queries, which is really nice. And then if you mouse over something, I'm just gonna click F1, I can get documentation on it right here inside of Android Studio. So I'm like, oh, okay, I can get some sightings. All right, great. All right, what is a UFO sighting? And then if I wasn't lazy and I didn't only add a description to date, then you would see description for all the other fields as well. And then over here in the index, you can see a list of all the queries and what they return, as well as their types. So while you're working with your GraphQL API, you don't have to keep jumping in and out using something like GraphQL. And then the other really nice feature, which I use a lot, is if I decide I want to get the short field, it's going to tell me, hey, you can't query that field short on a UFO sighting. So the fact that I downloaded the schema allows, once again, this plugin to know that's not a valid field according to the schema that you specified. So all within my IDE, while I'm working, I can get the benefit of not messing up and writing bad queries. Okay. Cool. The next thing is a client is optional. So even though I used Apollo Android for my sample application, GraphQL, once again, is just a specification, and it's just simple HTTP requests. So if for some reason the client is getting in your way, then just don't use it. One example is inside of our application, we were using a ORM. Our objects had to be in a certain format, and they were also in Kotlin, and Apollo Android creates all these Java classes. So we couldn't directly use them to store them in our database. So why would I download 5,000 objects, serialize them in this special format to just create 5,000 new ones in another format? So there's no point, just bypass the client. The next thing is there's a bunch of free GraphQL APIs. If you're still nervous about GraphQL, you can play with them. And studies show that 30% of the people that hear me say this today will still not play with them, but that's okay. For the rest of you, feel free. Here's a URL. You can find all of these APIs to test out. There's also a schema language cheat sheet that's available. So if you're ever confused, like what are all these exclamation marks and boxes and all this, you can get it from the cheat sheet. And I figure we should end with rapid fire true false questions. So first, GraphQL was designed for graph databases. It's rapid fire. False. Okay, yes, you can use any database you want or no database at all. It's not about that. Next, GraphQL is language agnostic. True, yes, this is really powerful. We've seen that there are various implementations in different languages from C# to Kotlin and everything in between. Next, Apollo Android is the only GraphQL client. Right, you don't have to use a client at all if you're not interested, or you could write your own in any language that you desire. Finally, REST is dead. Okay, yeah, you decide, right? I personally do not feel that REST is dead. However, people are really, really excited about GraphQL, and after working with it for the past 6 to 8 months, I too really enjoy working with GraphQL. So thanks for coming. Hopefully you feel like you've been able to get a grip on GraphQL. I really encourage you to follow up with the notes and slides and resources that are available on adavis.info. I'll be around for the remainder of the conference if you have questions or want to talk to me about anything Android, Kotlin, GraphQL related. Thank you. Now, time? Do we have any time at all?
Yes.
You do? Okay. So I can take a few questions now, actually, if people had questions.
How about using Graph with protobuf connection?
Could you repeat your question?
Yes, GraphQL can support protobuf.
Can it support protobufs?
Yes.
I'm not sure. I haven't tried to do that. Does
Okay.
anyone else know?
It cannot.
Okay, thank you, person sitting right beside you. Could I ask him? Next. Anyone else have a question? Yes.
Okay, have you been using GraphQL on your main projects in production?
Yes, I am. So we have a Ruby on Rails app that
the real
uses
question
GraphQL.
is testing.
Testing.
Yeah, when it comes to developing some features and backend developers making their endpoints not as fast, updating schema not as fast, so you're trying to mock things, and when you have only one endpoint and mocking it with awk HTTP mock server, it's not as easy as could be. So is there any tools to mock GraphQL in runtime for making some unit tests on your queries?
So
Thanks.
instead of unit tests, I'll use integration tests using mock web server, and that works perfectly fine. On the server side, it's a Rails app, so they just write it in their own little Rails specifications, and they haven't had any issues with testing on the endpoints. So that's how we are able to achieve it, not through any other means. So using mock web server. Also, if you look at the Apollo Android plugin code samples, they have many, many examples inside of the Android-test folder that use mock web server to test the library and the components. Okay, thank you. Anyone else?
Is there an alternative to using the Apollo client? Because I still want to use a client, but the Apollo client is very hard to use. Especially the schema generator, which uses npm.
So right now for Android, no, there's nothing else. But if, like I said, a client is optional. So if you wanted to, technically, you could just use retrofit, have some URL that goes to /GraphQL, and create your query strings like that. I do know there is a Kotlin library for generating GraphQL as strings. So it doesn't give you all of the fancy stuff that comes with having a real GraphQL client, but you could use it to just not have messy string interpolation everywhere and actually build up your GraphQL queries using real code. So that is available.
Thank you.
Yep. Anyone else? Okay, this person right here.
So I was wondering, we are exposing with GraphQL, we are exposing a query language publicly through an API. And I'm thinking about, are there any risks, vulnerabilities, for example, if you're comparing to SQL, injections, if you handle it improperly. So anything like that for GraphQL.
Yeah, there definitely are risks. Like you could have your front-end developers hate you and they could decide to have nested queries, 10 deep. But how are people addressing it? Well, since how the server works is it takes the query and it actually parses it into this sort of transformation, I'll call it. And so you can say, we don't accept any queries deeper than 3 levels deep. So that's in your control. Also, it's just a regular server. You should still have authentication. You wouldn't just world, here's my fancy GraphQL API. You still have to put safety guards in place. And then I showed you an example with KGraphQL, which is in beta, and it's very, very basic. But Apollo, Engine, and the big players in the field, they have more sophisticated means of protecting the GraphQL server. Okay, great. So once again, thank you so much. Find me later and grab the resources if you're interested.